So, in lecture number 2 in work energy power, now we discuss recall the previous class some important topic, the unit of work. So, some of our previous we discussed the what is work and what is positive work, negative work. Discuss here. Okay. Now we discuss the previous lecture some important units of work. Okay. So continuation of previous lecture discuss the unit of work. Unit of work. We know the SI unit of work is joule. So formula of work equal to force time displacement. Okay. And in previous lecture you know the force is a vector quantity and displacement also a vector quantity. So work done is a scalar quantity. Okay. So if force SI unit, consider SI unit, the force SI unit of force is Newton and displacement SI unit displacement is meter. So Newton meter and finally get a joules. Okay. Suppose 1 Newton 1 meter equal to 1 joule. So what is the serious unit of work? Okay, very easy. And in terms in class 9 physics, you know that 1 Newton that is equal to 10 to the power 5 dyne. What is dyne? Is the CGS unit of force. Okay, very important. Dyne is the CGS unit. And what is the relation between Newton and dyne? Class 9 physics, but here some recall. From Newton's second law, you know the force equal to mass time acceleration. So SI unit of force is Newton, 1 Newton. Mass, SI unit of mass is 1 kg and acceleration is 1 meter by 1 second square. Now convert in CGS, 1 kg to 1000 gram. G stands for mass, gram, meter to 100 centimeter and second is second square. So 1, 2, 3, 4, 5, that is a 10 to the power 5 gram centimeter per second square. That gram centimeter per second square is called dyne. That is 10 to the power 5 dyne. The CGS unit of force. So very easy. 10 to 5 dyne. And 100 meter, that is also equal to 100 centimeter. So finally get 10 to the 5 or 10 to the power 2 here. That is a 10 to the power 7 dyne centimeter. And that is a dyne centimeter. Another name of dyne centimeter is called arc. That is ERG. So 1 joules equal to 10 to the power 7 arc. Okay, there's a relation between SI and CGS unit of work. Okay, very easy concept. Now here little some discussion here. Just briefly discuss the component parts. Okay, what is the cos theta and what is the component part? Okay, we forget the previous class I discussed. Now discuss the component part. What is the component part here? Suppose in class 11 we detail discuss in class 11, but here some little discussion here for component or vector component. Okay, so if I draw a graph, a line that is a x-axis, that is a y-axis component concept, that is a concept. Okay, so is the object in that place here, object here, some force applied in that direction, force applied in that direction. Okay, that is a force. The force is a vector. No, the force is a vector. There is a magnitude and as well as direction. So in vector represent a vector in component wise. There is a x coordinate, that is a sum of x part of force, and there is a y part of force. Represent. Okay. There is a x part of force and there is a y part of force. So here the x part of force is called fx, and y part of force is also called fy. okay, fx and fy. If the body displays is like the body, this body displays in that direction. Okay, if body displays in that direction, so in direction the displacement. But definition of work, we know that in previous class we discussed. So 1 joule of work has to be done when 1 Newton force applied on a body or object get displaced in 1 meter in the direction of force. That's the important line in markup line here. In the direction of force, that's the important, in the direction of force here. So displacement also the so force in that direction. So need a force aligned with or parallel to displacement. That is a x direction. So what is the x component of force? How represent the x component? So suppose a vector f, suppose the fx, x component, that is a fx, x component of force. This means represent the x component of force fx, that is a magnitude, that is a magnitude, and there is some direction is called a unit vector, that is class 11 physics. But here's a little discussion here, but it's not important in class 10 physics. So that is the x component, maximum direction of x, okay, plus that is a y part of force, that means a component of force in y direction, fy, the magnitude of force in y part, and the direction is y cap. This represents a hat or cap. That is a direction, that is a magnitude. Magnitude, a numeric value, that is represent direction. Okay. If the angle is theta. So in trigonometric treatment here, we draw a perpendicular from force to x-axis at 90 degree. Yes, 90 degree, and that is fy. This is a fy, that's also fy perpendicular, that is fx. So displace x-axis, we need a fx component, not fy component. Okay, that's very important. We need only fx part, not fy part, because object displaced in plus x direction, not y direction. So now the in that is a given triangle ABC, that is a right angle triangle, and C is the 90 degree. From trigonometric ratio, that is, we want base part. The CB or BC is the base part, and we know the F, the hypotenuse, that is the F. F represent hypotenuse. So hypotenuse and base. We know the trigonometric ratio, that is hypotenuse or base, that is cos theta ratio. Trigonometric ratio cos theta. So base by hypotenuse, that is equal to cos theta. That's trigonometric ratio, basic trigonometric ratio. So that is base equal to hypotenuse times cos theta, and we know the base is the x part, that is fx, and hypotenuse represent the a cos theta. The simple work done, that is equal to fd, that is we need x part of force, we need x component of force. So that is x component of force, that is equal to f cos theta and times d, so that is equal to fd cos theta. It is also a concept here, okay, discussion how the vector dot product, okay, but in class 10 that is just basic concept, okay, that's not any question from here, what is the component, what is that, okay. Now clear what is the force, what is the x component, or what is the relation between fd cos theta in work done in component wise, that is a component wise discussion. Okay, now in case we discuss, um, uh, suppose if the example from suppose the variable work. Okay, so how we discuss the variable force in work. So variable force, very important point here. Discuss the variable force. What is the work done? Not important. What is work done? What is work when force is variable. What does it mean variable? The variables vary with time. Force change with time. Okay. Suppose draw a graph that is x, and that is also give an example of time, or displacement also be time, or displacement or time. That is a variable, a vary. Okay, that is represent of force. If displacement increases and force also increases here, like this, that is a force increases here. Okay. Is force increasing here? If some point of force, there is a some value here also. Okay, there is a variable. If x1 position, there is a force is f1, and in terms of x2 position, that is force is f2, and the displacement between these two, that is also the x2 minus x1, also called some capital X. What is work done when force is variable? So there's important or easy concept that if I draw a triangle, to get a shaded region here, some shaded region here. So these shaded region or area of triangle represent work done. Suppose A, B, C. This area represent work done. In terms of force is variable. So work done equal to force or this area. Area of a triangle represent work done when force is variable. Okay. Now here previous topic discussed, the force is constant. The force is constant. But here force is not constant. Force is vary. Force is not constant. Here the force is vary. Okay. So the area represent is very easy. That is represent the work done. So if the area of triangle equal to half base, the base is displacement, and into height, that is a change in force, that is called capital F. So F into X, and that is F into X also represent, if I ignore that magnitude part, that is also work. Okay. If we consider these two parts, that is a work. So here work we discuss the force time displacement. Okay, very easy. If there's another diagram too, very easy. If the here we discuss, if the another draw here, if that is x force, if body displaced from origin to here, and some force applied here, force applied here, so that is a total force and total. Now it is cover up these two. This is a force line, and that is a displacement line here, and get that area. This area also represent variable work done. So work done, that is equal to, that is a rectangle. We know that rectangle means area of rectangle, area. So in terms of area, there's a area represent a work when force is variable. Here we discuss the area varies. The rectangle area is length into breadth. So here length is x and breadth is f. So that is also called, that is also work done. So simple concept here. In case of variable force, also the in shaded area under curve. If area under curve or a shaded, here represent a force. Okay. So Next concept. Okay, so now we discuss the work done by the force of gravity. Work done by the force of gravity. Work done by the force of gravity. Okay, so force of gravity or gravitation force also act downwards. You know that. Mhm. So also act downward. So if some object here, then gravitation force, that is downward force of gravity, or represent the Fg, or also called a weight. Okay, the Fg, and if the body now displays the ground, okay, if there is some height h, a body now displaced from h height. So what is the work done? Fg times h. We previously discussed what is the force of gravity is also called that is a work, that is a weight, and weight represent in mg from Newton's second law, mass time acceleration due to gravity into h in work. So that is mgh. Okay, so there is a depend on height, there is a h, that is a height. So work done by the force of gravity depend on height. And what is the force? That force is gravitation force, or also called a weight, or weight, or weight. That is mg. Very easy. Okay. Now we discuss the another concept. We discuss the power. Okay. Very important point. What is power? Okay. What is power? Okay. The rate of doing work is called power. Simple concept. The rate of doing work is power. Work is power. Okay. So P W by T, work done by time. So if calculate the units, so P equal to W by T. So we know that SI unit of W is joules, by time is second. So joule per second is called watt. Is called watt. The SI unit of power is watt, equal to 1 joule by 1 second. If 1 watt equal to 1 joule by 1 second. So now define the 1 watt. What is 1 watt? If 1 joule work has to be done in 1 second, it is 1 watt power. Simple. If 1 watt power states that 1 watt power states that if 1 joule work has to be done in 1 second, so say that 1 watt power. Very easy concept. Okay. Now, so very easy concept. There is another relation between the uh, some build a relation, an algebraic relation. Okay, in terms of calculation of maths. So we know that power equal to W by T, some relation, and W equal to force times displacement by T. Now, if d by T, displacement by time is called velocity. So power equal to force times velocity. Another relation formula. Okay, force times velocity. So another concept is 1 Newton and times velocity 1 meter by 1 second square, that is 1 watt. There is that another relation. 1 Newton 1 meter square, 1 sorry, not square, that is only second. Okay, that is a velocity, not acceleration. 1 Newton per 1 second, that is 1 watt. That is another relation here. So now comes the in terms of CGS unit. discuss. So here the 1 watt in terms of CGS, that is also equal to 1 joule, means previously know that 10 to the power 7 arg per 1 second, that is also called 10 to the 7 arg second to the minus 1, is also called 1 watt. Another important unit of power is horsepower. Power is horsepower, very important. In huge machine like railway, loco engine, okay, any huge engine, we calculate the power, horsepower. Okay, so HP means horse power. What is horsepower? And uh, if 550-pound object in FPS from up in 1 feet in 1 second, we get a horsepower. So 1 horsepower pound object. Okay, 1 horsepower, that is also equal to 0. Uh, 1 horsepower is equal to 4746 watt. Okay, if one 550-pound object in 1 second up in or displaced in 1 feet, that is FPS. PS. Okay, so you get a horsepower, that is 746 watt. Okay, very easy concept. If asked what is horsepower, very easy concept. Mechanical engineering has a huge machine, lumps of huge engine calculate in measure in power, measure in horsepower machine. Now another important is difference between power and watt. First different unit, SI unit is watt. Second, that is a joules. Okay, another work is does not depend on time. Work, okay, that is W equal to F times D. Displacement does not depend on time, but power also depend on time, that is work done by T, that is depending on time. Mhm. That is very easy to follow. Okay, now we discuss the energy. Discuss the energy. Now what is energy? Energy is also the energy of body is capacity to do work. Is the energy present capacity to do work. Okay, that is a energy. So simple SI unit of also energy is SI unit, that is also joules. So energy is also joule, and CGS unit also are CGS unit also. Uh, in next class, we discuss what is energy and what is the relation between work and energy. Okay, why the both are unit are same. In this that discussion in next class. Here just only discuss the units of energy and very easy concept. Just simple mathematics calculation. The unit. Suppose one bigger unit of one. Suppose the power equal to work done by time. So W equal to P into T or P times T. So work done is joules. That's also represent the energy. So energy equal to P times T. So suppose the bigger unit is the if suppose 1000 watt in 1 second, that is equal to 10 to the power 3 uh, watt second, means uh, If 1000 watt means here also the 1000 joule also. So here discuss the 1 kilojoule, that is equal to 1 kilowatt in 1 second, that is 10 to the 3, both are multiplied 3. So 1 kilojoule we get 1 kilowatt in 1 second, it's both are multiplied kilos. Okay. Now what is watt hour? Now the concept is watt hour. What is watt? If watt hour means 1 watt hour means 1 watt. Now hour in time, convert hour to seconds, that is 3600 second. Okay, so means watt second, and that is a watt second represents joules. So means 3.6 into 10 to the power 3 watt second. 3 because point here cancel down 10 is, that is point release, we get 10, that is 10 to the 2. That's simple 3600. Suppose now we ignore this and sorry, suppose now 3.6 into 10 to the power 3 watt seconds means 3.6 10 to the power 3 means joule. Now 10 by 3 represents kilo. So 10 to the power 3, 3.6 joule. So 1 watt hour equal to 3.6 kilojoule. Very important. The watt hour represents kilojoule. Now here another important is, if kilowatt hour, uh, kilowatt hour, watt hour. What is kilowatt hour? Kilo means suppose kilowatt hour, HR represent. If kilo means 10 to the power 3 watt, hour represent to second, convert 3600 second. So here we convert 10 to the power 3 into 3.6. That's mathematics. So 10 to the power 3 watt second, that is joule. So 10 to the power 3 and exponent, that is 10 to the 3 and 10 to the 3, the multiplication base are same, power also same, so added these two. So that is 10 to the power 6 watt second. So that is 10 to the 6 watt second represent 3.6, 10 to the 6, no, that is mega. Watt second represent joule. So 1 kilowatt hour represent 3.6 megajoule. Okay, so another unit of energy is a heat energy, and another form of energy. Okay, the another form of energy, is heat. So if heat energy also the SI unit is SI unit joules. Okay, so that is joules. Okay, suppose if someone asks, if some in our house the electricity power supply company is a power in our house. Okay, so suppose you check the meter reading, that is 1 unit, 10 unit, 30 unit, 40 unit, that is 1 unit means to 1 kilowatt hour. Okay, 1 kilowatt hour, that is a 3.6 megajoule energy we used. 1 unit means 3.6 megajoule energy we use in our house in 1 hour. Okay, that is simple concept. In where discuss in class, discuss topic in electricity or household circuit, the discussion what is the measurement of units in the electricity company, how to measure the units in electricity company. Okay, but here that is also represent only energy in that class. Okay, so that is a heat is another form of energy. So simple 1 joule in class 9 you know that is sorry, the 1 calorie. Okay, there's another form of energy unit is calorie. So 1 calorie that is equal to 4.2 joule. 1 calorie, that is also 4.2 heat energy. Okay, so what is the heat? Calorie. Calorie represent the terms in centigrade temperature. If 1 degree centigrade rise or fall in 1 gram of water, that is CGS. That is a CGS form. If 1 degree centigrade rise or fall in temperature in 1 second we get 1 calorie heat is, if rise, so 1 calorie heat is absorbed. If 1 calorie degree is fall, 1 degree centigrade is fall, so 1 calorie heat is release. That's very important. Okay, clear what is calorie and 4.2 joule? Okay, that is class 9 physics. Okay, here just basic idea. So if we have a discussion here, some recall. If 1 degree centigrade rise means temperature rise, heat is absorbed. So 1 calorie heat is absorbed. If 1 degree centigrade is fall, okay, so 1 calorie joule heat is released. So 1 calorie, so not joule, 1 calorie heat is released. So 1 calorie means 4.2 joule heat is released. Okay. That is related in basic concept, that is 1 gram of object. Okay. Or simple 1 gram of water. Now another form of energy is called electron volt. Electron volt. Simple for E and V. Electron volt. What is electron volt? The energy transfer from one atomic particle. If one atomic particle energy transfer of one atomic particle. Okay, that is 1 eV. So we know that 1 eV represent suppose very easy concept. So 1 eV, that is equal to charge of 1 electron. We know that charge of 1 electron charge and 1 volt. Okay. Uh, so electron charge is 1.6 into 10 to the power minus 19 coulomb times V, coulombs and volt. That is also that coulombs or volt represent that joules. 1.6 10 to the power minus 19 joules. So 1 eV means 19 joule. In discussion of electricity, charge flow, what is current, a detailed discussion that class. Okay, not here. That is basic idea. Type of a form of energy here. The another form of energy of heat, another form of energy is electron volt. Okay. So here the last topic today. What is energy? Difference between energy and power. Difference between energy and power. Difference between energy and power. Very easy. So first difference is energy, SI unit of energy, that is a joules, that is a watt. Okay. Second, okay. So energy spent does not depend on time. Energy doesn't not time. So like work depend time, spend time. Now the third, energy of capacity to do work, definition, capacity to do work, and power is rate of work, rate of work. Okay, rate of work. Okay, is power. That is the three basic difference. Okay, easy. Here we discuss the basic idea of work and energy and power. Let's just discuss on the basic idea. Okay, the previous two classes discuss the basic idea. Okay, so any doubt in that class, put in comment section. Okay, I will try to give the answer. And next class we discuss some numerical problem. Okay, numerical problems of basic class 10 board exam numerical problem, previous year numerical problem. Okay, so today I end up class here. Thank you.